A random variable x represents a numerical value associated with each outcome of probability experiment. In this class, we're going to discuss two types of variables. A random variable is called discrete, and it has a finite or countable number of possible outcomes that can be easily listed. A random variable is called continuous, and it has an uncountable number of possible outcomes represented by an interval on a number line. For example, let x represents the number of banks in San Jose, California. Because of the keyword the number of, you have a discrete random variable. Let x represent the speed of a rocket. The speed is not countable. It's an example of continuous random variable. Let x represent the volume of an engine. Volume is not countable. It is a continuous random variable. Let x represent the number of students in the class. The number of means you have a discrete random variable. And finally, let x represents the area of a floor. The area is not countable. It's a continuous random variable. What is a normal distribution? A normal distribution is a continuous probability distribution for a random variable like x. The graph of a normal distribution is called the normal curve. A normal distribution has important properties. First of all, when you're looking at the measure of center, mean, median, and mode, they are all equal to each other. The normal curve is bell-shaped and it's symmetric about the mean. The total area under the normal curve is equal to 1 or 100%. The normal curve approaches but never touches the x-axis as it extends farther and farther away from the mean. Between mu minus sigma, which is population mean and population standard deviation, and mu plus sigma, again, population mean, population standard deviation, the graph curves downward. The graph curves upward to the left of mu minus sigma and also to the right of mu plus sigma. The points at which the curve changes from curving upward to curving downward are called inflection points. Let's take a look at the graph. As you can see, the center is located in the middle, represented by mu. If you're working with a sample, it is x bar. The total area below the curve is 1 or 100%. And as you can see, the graph never touches x-axis. It just extends indefinitely. The function that has the following curve is f of x or y equals to 1 divided by sigma times square root of 2 pi e to power negative x minus mu to the second over 2 sigma squared. The pure number, which is about 2.718, and pi, which is about 3.14, help to describe this function. When you're using Python or R, this function is already defined in your library. So we just need to call that function and use it. What is the standard normal distribution? There are infinitely many normal distributions. Each they have own mean and standard deviation. The normal distribution with a mean of 0 and standard deviation 1 is called standard normal distribution. So when you're referring to standard normal distribution, mean is always 0 and standard deviation is always 1. It helps us to normalize or scale a normal distribution. The horizontal scale of the graph of a standard normal distribution corresponds to z-scores, not x values. We take x values and then we convert them to some new numbers that we call z values. The formula that helps us to change x values into z values is as follows. Z is equal to the x value minus the mean divided by standard deviation, or x minus mu over sigma. Make sure you round to the nearest 100. So we especially use these if we have a data that are confidential and we are not allowed to publish those data. We convert them into Z, or it provides a same language, same number that every statistician, every data analyst can understand. When it comes to probability, especially probability distribution for a continuous random variable, we are interested in calculating the probability either to the left or right or in between numbers. For example, by looking at the graph here, this is representing the graph for standard normal distribution. As you can see, you have Z here. On the horizontal line, you have a Z, and the center is located at 0. We can use table, or we can use calculator, or any software that help us to do the calculation for probability. The area to the left-hand side of 1.23 is about 89.07%. So this number represents this area or probability. For example, if you're interested in finding the area or probability to the right-hand side of 1.23, logically we say that, hey, the total area is 100% minus the area to the left, which gives you the area to the right. So this 1 is the total area. The area to the left is 0.8907. If you do the subtraction, you get this little area to the right-hand side. And finally, if I ask you to find the probability or area bounded between two numbers, logically, you're going to say that, hey, the area to the left-hand side of 1.23, which is this larger area, is 89.7%. The area to the left-hand side of negative 0.75 is this area, which is 0.2266. If you do the subtraction between them, you get the middle area, which is 66.41%. So again, the area to the left, this is cumulative area. The area to the left-hand side of 1.23 minus the area to the left-hand side of negative 0.75 gives us the middle area, which is 66.41%. So in this class, we're going to learn how to run different codes and calculate the probability. Question says, a survey indicates that people keep their cell phone an average of 1.5 years before buying a new one. The standard deviation is given to us as 0.25 year. A cell phone user is selected at random. Question wants us to find the probability that the user keep their phone for less than 1 year. Well, assume the length of time people keep their phone are normally distributed and are represented by X. So let's take a look at the figure. We have a standard normal distribution. No, this is just a normal distribution. Remember that for a standard normal distribution, the mean must be equal to 0, but the mean is 1.5 with standard deviation, which is 0.25. The center is located here, which is 1.5 years. Less than 1 year is going to be this little area, this probability to the left side of 1. You can convert everything into Z. The Z-score is going to be X minus mu divided by sigma. X is 1 year, mu is 1.5 years, and sigma is just 0.25. So if you do the division, you get Z equals to -2. So the way that you can normalize this is convert X into Z. and the probability that z is less than -2, which is the same as the probability that x is less than 1, is a small probability. This probability is about 2.28%, which is very small probability. We expect that this area here is the same as this number representing the total area out of 100%. What is the code behind it? So what are we going to use? We're going to use scipy.stats norm. Scipy.stats norm is a sub-library of scipy.stats that is used working with normal distribution. Again, everybody, out of a lot of libraries that are available, we're going to use this sub-library. The normal distribution is an important statistical distribution. It's used in finance, business, physics, engineering, and so on. Scipy.stats norm provides a range of tools for working with normal distribution, including probability density function, cumulative distribution functions, and random number generator. The function that we described for a normal distribution is built into this library. The norm object in scipy.stats encapsulates the formula that we introduced for a normal distribution. It provides methods for computing probabilities, percentiles, and other statistical related topics. So first, I want you to import norm from scipy.stats. From scipy.stats, import norm. This imports the norm object from scipy.stats module. The norm object represents a norm continuous random variable. Then let us set the mean and standard deviation. As you remember, mean of the data is 1.5, so we define a variable mean and assign 1.5 to it. Then standard deviation, which we represent by a std underscore dev, let us set it to 0.25 as it defined in the question. Now, what I want you to do, I want you to set the threshold equal to 1. And then to calculate the probability using cumulative density function or CDF, define probability to be norm.cdf. The threshold is equal to 1 because it's less than 1 year to the left-hand side of 1. And then you're going to use mean and you're going to scale using standard deviation. This line calculates the probability using the cumulative density function. The CDF function takes the threshold value, which is 1, and parameters LOC, which is your mean, and the scale, which is a standard deviation, to compute the probability that the value from the distribution is less than or equal to the threshold. The probability is going to be very accurate. It is 0.02275 and so on. So as you can see, the value that Python calculates for us is very similar to the value that is given in the question.